Looking at example 1 from section 6.2, this is the optimization section. This is the section that is the application of finding the absolute maximum and relative maxima and that sort of thing. So in this particular case, we want to maximize this quantity here, x squared y. This thing right here would be called the constraint for this particular problem, so let's call it that. So now on your list, either in the book or on the worksheet for 6.2, you have a list of all these 6 things that you want to sort of follow when you're trying to optimize something or maximize or minimize something. So read the problem carefully, make sure we understand what is given and what is unknown. If possible, sketch a diagram. We're not going to be able to do that here. Decide on what variable must be maximized or minimized. So in this case, this is the thing we want to maximize. It's a product, so we might want to use the letter P to say we're going to maximize P. So P is a product, and we want to maximize P. Okay. Find the domain of the function. Well, both of these have domain, all real numbers, so that's fine for this one. Critical numbers. Okay, so now what we want to do, since we're trying to maximize this, we have got 2 variables in there. We're supposed to eliminate one of these variables using the constraint. And in this particular case, I think it's probably easiest to, in fact, actually, I don't know, in this case, it doesn't seem to matter actually whether we solve it for x or y. What we're going to do is we're going to take that constraint and solve for one of the variables. Let's go ahead and solve this one for x. So we get x is equal to 30 minus 3y. Okay, and then what we can do with that constraint is we can now plug it into the thing that we're trying to maximize. So in this case, if I do that, we'll get 30 minus 3y. It's squared, and then we've got another y there. Okay, so now the next step, it says if the domain is closed, it's not closed, so we're not going to care about that. Evaluate the function at the endpoint. If the domain is open, apply the critical point theorem when there's only one critical number. If there's more than one, then we have to evaluate it at each of them. So next thing we want to do here is just evaluate or find the critical numbers for this thing. To do that, we're going to need the derivative. So the easiest way, I think, to find this derivative is to go ahead and expand this thing. So to expand it, remember this will be like 30 minus 3y times itself. That's what squaring something is, so don't make that a mistake where you just square the first and the last one and subtract them. Squaring something means to do this. So we'll write it twice and expand it as much as we can. So if we go ahead and expand that, we'll have 30 times 30, that's 900. Then we'll have minus 90, and then we'll have minus another 90, so minus 180 y. And then the last term, we're going to have 9y squared. And this is all still multiplied by that other y there. So let's go ahead and distribute that y. We'll get, let's go ahead and write this in the way we usually write a cubic polynomial. So we'll get 9y to the 3rd power. Distribute the y here, we'll have minus 180 y to the 2nd power, and distribute it there, I'll get 900y. Okay, so next thing we want to do is take the derivative of this thing, find the critical numbers, so we'll get p prime of y is equal to 27 y squared, 360 y, and 900. And I think we can probably factor this. I'm going to let my calculator do the factoring today, but remember, this is an online class, so you can go online and find some kind of factoring website that will do that for you. So let's see, factor 27 y squared, 360y, 900. Okay, so my calculator tells me that this factors as 9 times y minus 10 and 3y minus 10. Okay, so now remember we're going to set all of these equal to 0. 9 equals 0 doesn't work, so we're going to get two solutions out of this. Y is equal to 10 and y is equal to, if I set that to 0 and solve it, I'm going to get 10/3. Okay, so there's our two critical numbers. I'm kind of running out of room here, but hopefully we can squeeze it all in. All right, so now we want to decide which of these two is actually going to give us a maximum value. So if I plug in 10 here, notice if I plug in y equals 10, in fact, actually I need to find x as well. So let's do that. Let's find x as well. To find x, we'll just use that right there. So if we do that, we're going to get x is equal to 30 minus 3 times 10. Notice what that gives us. We're going to get 30 minus 30, which is 0. Okay. Now it does say to find two non-negative numbers so that this thing is maximized. Well, 0 is definitely non-negative, but notice that if we use 0 and 10, what's going to happen? We're going to get p equals 0. Okay, so if the other one gives us a larger number, then that's the one we're actually going to be interested in. So this is if y equals 10, and then the other one, if y equals 10/3, then what do we get for x? We get x is equal to 30 minus 3 times 10/3. Now notice what happens in this case. The 3's are going to cancel. I'll get 30 minus 10, that's 20. So if y equals 10/3, then x is equal to 20. That's going to give us a larger number than the other one. The other one would give us 0. In this case, we're going to get 20 times 10/3, that's 200 over 3. So that's the one we're looking for. The two non-negative numbers that we want then are going to be, the two numbers are going to be x equals 20 and y is equal to 10/3. Okay, so that's our answer for this problem. Two numbers that when multiplied together give us the largest possible value, the maximum value, with this particular constraint, provided that x plus 3y is equal to 30. So with that constraint, these two numbers are going to give us the maximum value when we plug them into there. Okay?